First things first, what is an imaginary number? And then what about the definition of an imaginary number makes it imaginary? So an imaginary number is the letter I. What does I equal? The square root of -1. Okay, so this, if they say what is an imaginary number, it's I, and I equals the square root of -1. What about this makes it imaginary? Caroline? Perfect. There's no number times itself that is going to equal a negative. Okay, that's the exact reason behind it. It's imaginary because it's impossible. Okay, and it's impossible because there's no number times itself that will equal a negative under the root sign. So then what is the general form of a complex number in all letters? What is it? General form of a complex number. Yes, A plus BI. And what does each of these pieces mean? What does the A represent? A real number. And the BI? Imaginary. And that's why it's called complex, folks, because it has a real piece and an imaginary piece. That's pretty complicated, okay, to be real and imaginary. All right? And that's what that is by definition, okay? So that's the general form. That's what each piece means. Boom. Okay? Those things need to be up in that noggin swishing around. Next, we have a graph, okay? And I put up some of my work already for this. We start off with what we know, which is our vertex. To do the vertex, I kind of started it over here, negative b over 2a. So negative of positive 6 is negative 6. Over 2, my a is negative 1, so negative 2, negative 2. Negative over negative is a positive, 6 divided by 2 is 3. So we have to take that 3 and plug it into our equation to get out the y. I want to remind you that any number squared, you do that first and then apply the negative after. That negative is a coefficient, folks, okay? So you end up with -9, and then 6 times 3 is 18, and we go left to right. -9 plus 18 is 9. 9 minus 5 is 4. So our vertex is right here. Off of that vertex, we do our axis of symmetry. The equation for that would be x equals that number, 3. And then our y-intercept is just our c value here. I plotted it at -5, and I reflected it over the line. Moving forward, if there are x-intercepts, you need to graph them. Okay? And again, x-intercepts are just the solutions, okay? Your x equals pieces when you solve. So if you do GCF, if you do difference of two squares, if you do perfect square trinomial, or factoring, which is what we talked about last class, that's what you do here to get these numbers. So first things first, I'm going to check. I can't GCF this because it's not two pieces. It's not a difference of two squares because it's not two pieces. And it's not a perfect square trinomial because that's not a perfect square. So I have to factor this now, okay? So I'm going to kind of create my little, I'm going to scroll all the way down. I'm going to create a little table. Let's go over here. What multiplies to be my A times my C value. So what multiplies to be 5 and adds to be my B value, which is a positive 6. So what multiplies to 5 and adds to 6? That's nice, right? 5 is prime, so the only thing that's going to work there is 5 and 1, or -5 and -1, right? But we want a positive 6 here, so it's going to be 5 and 1. So I'm going to rewrite this in 4 pieces. -x squared plus 5x plus 1x minus 5. I'm going to group. Now, I'm going to talk to you about what we could have done instead of this at the end. Okay, so just, if you're thinking, could we do a shortcut here? Our a value technically is not 1. All right, it's -1. So that's why I'm going through all the steps. We'll come back and talk about that afterwards. Okay, so I'm going to GCF each of these. I'm going to pull out an x. If you wanted to pull out -x, you could. Did any of you start doing this? You got to there. What did you GCF out? Did you do an x or -x? Okay, so let's pull out the -x. Okay. So negative over negative is a positive. X squared over x is just x. 5 over -1 is -5, and the x's cancel. So I want this to match this. And what do I notice right now? They're pretty close. They already match. Yeah, they're pretty close because there's a 1 here, right? But the x is +1, the -5, -5. You still have to GCF something out of here. What can I pull out of each of these pieces that won't change anything? 1. You have to do that, okay? You have to have a binomial, which means you have to have 2 outside pieces to be able to put in a parentheses. And then I still have my x minus 5. So now I'm ready to put it into its factored form. Remember, factored form is our outside stuff, so negative x. And then this is a positive 1, so I'm going to put plus 1. Times my repeat piece, so one of these, x minus 5. Now I set each of those equal to 0 and solve. So I'm going to put minus 1, so I have negative x equals negative 1. Divide by negative 1, divide by negative 1. Or I could just say if negative x is negative 1, positive x is going to be positive 1. So one of my intercepts is at 1. And then here I would add 5, I get x equals 5. So my two intercepts are going to be at 1 and 5. So look at this. I'm going to go over 1. I'm going to go over 1, 2, 3, 4, 5. Look at this in reference to our axis of symmetry. 1, 2, 1, 2. Oh my gosh. See how they work? And see how if I connect all of my dots now, it's like this beautiful curve. Okay? That's the expectation from this point forward. 5 points. If there's 5 points that you can do. Your vertex, your x-intercept reflected, which is going to be both your x-intercepts anyways, and then your y-intercept reflected. Moving forward, when you're asked to graph, this is now the expectation. Okay? Not just this point and these two. So, complex numbers, again, going back to our sit and begin, we have a plus bi. Okay? That is our real piece and our imaginary piece. So with addition, all we have to do is combine like terms. Okay? So we're going to take our whole numbers and we're going to add them together. So everybody, what's 5 plus 2? 7. Those are like terms. Now we're going to look over here. This is an I term, right? And this is another I term. We're not multiplying, we're just adding them. So what is negative 7 and positive 4 together? Negative 3 i's. That's it. So my first step is I send this negative across. So instead of being a 3, negative times 3 is negative 3. Negative times negative 6 becomes plus 6i. And then I just cross that off. And now I can combine like terms. Okay? So now I just add those two things together. So I'm going to look. I have 4 and negative 3 together is 1. I have a negative 8i and a positive 6i together is negative 2i. You could get that when you subtract stuff, your I value is totally gone. They could cancel. That could happen when you add also. Your real piece could go away. Your whole thing could go away. It could be nothing. It could be 0, right? There's lots of options here. But you're never going to have anything bigger than a binomial looking like a complex number with your real piece first and your imaginary piece second. Okay, so let's look at this one. 6 minus 8i times 9 plus 2i. I'm going to double distribute. I'm going to start with my positive 6, and I'm going to send it to the 9 and to the 2i. So 6 times 9 is 54. 6 times 2i is going to be a plus 12i, right? Positive, so we put plus. 6 times 2 is 12i. Now I'm going to come to my negative 8i. Remember, it's not just 8i, it's negative 8i. We're going to times it by the 9 and by the 2i. So negative 8 times 9 is negative 72i. Negative 8 times positive 2 is negative 16. And then what is I times I? I squared. Okay? And right when you see that, and I know it's been a little while since we talked about it, but right when you see that I squared, you should say to yourself, that is equal to negative 1. Okay? So right now, once you start that multiplication, once you get your 4 pieces, your next step is to cross out that I squared and put a negative 1. Okay? So now you essentially have negative 16 times negative 1. Doesn't do much changing, right? What's negative 16 times negative 1? Yeah, all that negative does is change this sign. So this is going to become a plus 16. Okay? So now I can look at all 4 of these pieces and combine like terms here, just like I would if I was traditionally foiling, okay, or double distribution. I have my real pieces, 54 and 16. They're both positive. I'm going to add them together. So 50, 60, 70 exactly. So I put my real piece first, right? It goes real plus or minus your imaginary piece. So make sure you write your answer in that form also. Then I have a 12i and a negative 72i. So different signs subtract, it's going to be negative 60i. There's no I squareds in your answer because we already simplified it out to make this a constant. So let's head back to our notes, folks. Now we've talked about adding, we've talked about subtracting, and we've talked about multiplying. And all three of those strategies, folks, are the exact same things we do if I was a variable, okay? Except for when we get to the multiplying, we have that one simplifying piece, right? It is absolutely, totally different with division, all right? I want to be very clear with you. It is absolutely, totally different with division. So you need additional knowledge, obviously, and it's going to be a little bit more challenging, okay? So when you have a division problem, you have two things that could happen, and it's imperative, okay, that you notice which one's happening first, or what's going on in the problem before you try to solve it, okay? Both of these two problems are division problems, right, because they're a fraction, okay? In this one, we're dividing by a complex number, right? It has both a real and an imaginary piece. Agreed? In this one, we are dividing by only an imaginary number. You see that? You have two different strategies based on what that denominator looks like. So if your denominator is complex, we're going to have to find a conjugate and talk about what a conjugate is, all right? If your denominator is just imaginary, we're just going to get rid of the I, okay? The way that you divide these, folks, or you're done dividing when there's no imaginary piece in the bottom. So let's say you had, for example, 2 minus 3i over 5. Okay, that over 5, is it imaginary? Nope. Is it complex? Nope. It's simplified. You're done. Unless you can divide each of those pieces by 5, okay? The idea and how you know you are done these problems is when there is no I in the denominator. That's what you want to get rid of, okay? So let's start out actually with this one, because this one's going to be easier to get rid of the I. Think of what we've been doing and just did in multiplication. There's a time that the I cancels out and becomes real, right? When does that happen? When instead of I, it is squared. So all we need to do is make this an I squared. So what would we do to this chunk that would change that I to the first to an I squared? You would multiply the denominator by I, right? But guess what? What you do to the bottom of a fraction, you have to do the top also. So I'm going to multiply both the numerator and denominator by I. That is what you do every time that your denominator is purely imaginary. Okay? And then we can see what's going on. So let's start with our denominator. Okay? What is 5i times I? 5i squared. We're going to leave it like that for now. Okay? Then I'm going to come to my numerator here. I have a binomial times a monomial. What do I have to remember to do with this I? Distribute it, yes, to both pieces. It's not just going to the I there. It's got to go to both chunks, right? This is a binomial times a monomial. It's got to go to both. So I times 4 is 4i. I times I is going to be a positive I squared. So now we are going to simplify the Cordolios out of this, okay? Can I simplify 4i? No, so I'm going to leave it for now. Can I simplify I squared? 2, negative 1, okay? Can I simplify anything here? Yes, 2 and negative 1 again. Now I'm going to simplify. Now, your numerator needs to be written in the correct form of a complex number, which means its real pieces first, its imaginary pieces second, right? What's the real piece in this now? Negative 1. So we're going to put negative 1. And then is this a positive or negative 4? Positive. So I put plus 4i over, what's 5 times negative 1? Negative 5. Can I divide by negative 5 here and here? Nicely? 1 divided by 5 is not nice. 4 divided by 5 is not nice. You could stop here. Okay? Now sometimes, and I think Khan Academy maybe wants you to simplify it further. They might want you to write it as sending your negative 5 here and here as denominators. So we would have negative 1 over negative 5 plus 4 over negative 5 I, which means that we simplify out some of our signs. A negative over a negative would be a positive 1/5. Positive 4 over negative 5 would be minus 4/5 I. Okay? These are both correct answers based on how they want it simplified, and we'll make sure we know before you get onto Khan Academy which one to do. Okay? So here we just made sure our denominator was real, and we stopped because these were not divisible nicely. Okay, those coefficients and that constant. Or you could still send the negative 5 to both as the denominator and simplify and just have fractional constant and a fractional coefficient. That's fine too. I will accept either personally, but we'll have to make sure we're very particular when it comes to Khan Academy. Let's take a look at this one. So that is if your denominator is purely imaginary. That's nice. It's pretty easy, right? Get rid of the I by making it I squared. I could ask you a similar question here, right? There's an I in the denominator. That's the no-go. Can I multiply that bottom by something that's going to make that I squared? And you might say, yeah, we can send an I to it, right? So then I'll have 6I squared, but then what happens when you send it over here? 3I. It's imaginary again. So you're like, oh, times it by I again. Well, then that 3I is going to have a 3I squared, and then this one's going to have an I. You see what I mean? If you just times it by I, you're always going to have an imaginary piece. So instead, to solve this one, you have to find the conjugate. Has anyone heard that word before? No. Conjugate, okay, kind of. So, yeah, it's not really going to work out that way like it does with a language. So a conjugate is going to be something that I can multiply to this that's going to cancel out the imaginary piece, okay? And we actually do kind of use the idea of a conjugate when we have a difference of squares, but that doesn't matter right now. You'll just see how it works, okay? They're very easy. Okay, the conjugate to this denominator is going to be this denominator with a different sign there. Okay, so it's still going to be 3, and it's still going to have a 6I, but instead of adding those, I'm going to subtract them. Okay, and I want to prove to you that that works. So I'm going to have to times it anyways, right? So I'm going to times it on the bottom and times it on top, and I times it by its conjugate, which is just the middle sign only changed. Okay. When I do it to this denominator, it's a binomial, look, times another binomial. I just went over how to do this, right? We just did practice on multiplying these. We have to double distribute. So I'm going to do 3 times 3 is 9. 3 times negative 6I is negative 18I. Then I'm going to come over here. Positive 6I times 3 is plus 18I. And positive 6 times negative 6 is negative 36I squared. What's going to happen here? Yeah, look at those middle terms. Gone, gone. You might be like, but Mrs. White, still doesn't work. It does, because I squared is equal to negative 1. So this becomes 9 instead of minus 36, right? It becomes plus 36. My denominator right now is 45. See how by multiplying it by that conjugate, it canceled out our imaginary middle pieces, and then because the I squared by definition is just negative 1, it made us have a beautifully nice constant number as a denominator. Now, once we simplify our numerator, we're going to be done, okay? So up top, I have a monomial times a binomial. How do I simplify that? I need to remember to distribute it. Thank you. Okay, here and here. So 2I times 3 is 6I. 2I times negative 6, 2 times negative 6 is negative 12. I times I is I squared. I know that's going to be a negative 1. And I'm going to write this in the correct order now. Okay, because remember, it has to have real and then the complex. So negative 12 times negative 1, right? Negative 12 times negative 1 is going to be positive 12. This is already a positive 6i. And then I'm going to put the whole thing over 45. Now again, I could send this 45 to both of these. In fact, I can simplify this. I actually can't even keep it like this. Okay? This is not as simple as it can get because there's a number that goes into 12, 6, and 45. What are each of those constants divided by? Able to be divided by? 3. So you need to divide a 3 out of everything. And it just goes away. Okay? You're pretty much just simplifying this fraction. A 3, a 3, and a 3. So we end up with 4 plus 3 divided by 6 is 2, or 6 divided by 3 is 2i over 15. And then you can look at that again and say, can I do anything there? No. Okay? You could rewrite it as two fractions where I send the 15 here and here, so I could have 4 15ths plus 2 15ths I. Both of these are correct. Okay, this one is not because you can factor out a 3. You can simplify this big fraction. And it has to be able to come out of this number, your coefficient, and the denominator, all 3 parts. Okay? So big idea, let's summarize this quickly, okay? First step, determine is it imaginary in your denominator or is it complex? If it's imaginary, you just times the top and bottom by I. That's nice. If it is complex, you find the conjugate, which means just change the middle sign. Times that by the top and bottom, and then simplify. Okay? You know you're done when your denominator is a real number, and your top is at the most a complex. Okay? First thing you do is you look at the denominator. What do you notice about that denominator? It's complex. So to solve this, we need to, find the conjugate. Okay? And I guess you kind of conjugate it. You change it, right? You change it so it works. That's fine. What is our conjugate to this, folks?
5 minus 3 minus 5.
Yeah, it's just 3 minus 5i. You only change the middle sign. Okay? So write this down and times it by 3 minus 5i on the top, 3 minus 5i on the bottom. Write it down. So if we go all the way through that, and I tried to just put my work up quickly. I gave you some time to get going on it. All right. We end up with a negative 6i plus 10i squared. We simplify it, make sure it's in the correct complex number form. Then when we double distribute FOIL, right, our denominator, those pieces and parts cancel. I'm left with 9 plus 25, which is 34. All of these numbers are divisible by 2. So our problem is 2 plus I over 1 minus I. I'm going to look at that denominator. What do you notice about the denominator? It is complex. So to solve it, we need to multiply it by a conjugate. What is the conjugate to 1 minus I? You got it, Olivia. 1 plus I. Now this problem is different from the other ones because look at our numerator. It's complex and this is complex, so I'm going to have to FOIL the top and the bottom. Okay? But the bottom is the only part that needs to turn out nice. So I'm going to actually do that. 2 times 1 is 2. 2 times I is plus 2I. I times 1 is plus 1I. I times I is plus I squared. Now I'm going to go to the bottom. 1 times 1 is 1. 1 times positive I is positive I. Negative I times 1 is negative I. Negative I times positive I, is negative I squared. So there's a lot going on here, okay? I'm going to simplify first before I worry about simplifying my numerator and denominator together, okay? So 2I and 1I together, these two pieces, right, are going to be a 3I. This I squared becomes negative 1. There's no anything to multiply it by, so it's literally just 2 and negative 1 together, which is going to be 1. So I end up with 1 plus 3I. Okay? Then I'm going to look at my denominator. This cancels, right? Now I have I squared, which is negative 1. Be careful, this is still a minus, right? Negative times that negative means we're actually going to have a plus 1 here. You don't have a denominator of 0. Okay? I have 1 plus 1, which is 2. Can I simplify those three numbers at all? No. So I could write it like this, or I could have 1/2 plus 3/2 I. All right?